Just after midnight, on the 2nd of September, 1859, two telegraph operators, one in Boston, one in Portland, Maine, agree to try something. They switch off their batteries, every power source on the line disconnected. By every rule either of them knows, the wire between those two rooms is now dead metal, and the wire keeps working. For the next 2 hours, they hold a conversation down 300 miles of copper, with nothing pushing the current but the sky. And it comes through cleaner than it ever did on batteries. You're listening to Lost Signals, and tonight's transmission comes from the last time the sun reached down and took hold of the wires. 1859. The telegraph is barely 30 years old, and it is the only thing on this planet that moves faster than a horse. For about 18 hours, it stops belonging to us. Sparks come off the poles, paper catches fire on the desks, men are thrown out of their chairs by machines that are switched off. And over all of it, the sky turns the color of blood over Havana, over Hawaii. To understand what happened, you have to understand what had just been built. By 1859, the northern half of the world is strung with wire. Tens of thousands of miles of it, beside the railways, across the prairie, over the mountain passes. The first nervous system this planet has ever had. New York to Chicago used to take days. Now it takes minutes. They had tried the Atlantic too. A cable went down in '58, carried a few hundred messages, and died inside a month. So on this particular night, Europe and America are still two separate rooms. The storm is about to hit both of them, and neither one can warn the other. The 1st of September. Late morning, in a village south of London, a brewer's son named Richard Carrington is doing what he does every clear day, projecting the sun through his telescope onto a screen, tracing the sunspots by hand. There's a large group that week. He's been drawing it for days, and at 18 minutes past 11, two beads of white light appear inside it. Not brighter than the sun around them, brighter than anything he has ever seen through that instrument. He runs for a witness, anybody, to stand there and see this with him. By the time he's back at the eyepiece, it's fading. 5 minutes, beginning to end. Miles away, an astronomer named Hodgson is watching the same thing. Carrington writes it up carefully. He is a careful man. And then, 17.5 hours later, the Earth's magnetic field comes apart. That number is the strange one. Material thrown off the sun normally needs 3 or 4 days to reach us. This needed less than a day. The best answer we have is that it wasn't traveling down an empty road. 4 days earlier, on the 28th of August, another storm had already come through and swept the path clean. The first eruption cleared the way. The second one ran down it. So, the night of the second, high in the Rocky Mountains, a party of gold miners wakes up. Not to a sound, to light. It is bright enough to read ordinary print by, and some of them are certain that morning has come. They get up, and they start making breakfast. In the Northeast, people stand in the street reading newspapers at 1 in the morning. In Havana, the sky is deep red from the horizon to straight overhead. The same in Hawaii. The same in Colombia, a few degrees off the equator. There are towns where people gather outside, certain that the city over the hill is burning. Others take it for the end of the world. And nobody on earth had a better explanation to offer them. And while the sky is doing that, the wires begin to wake up. Telegraph poles throw sparks, not as a figure of speech. Sparks off the insulators, visible in the dark, all down the line. In Washington, an operator named Frederick Royce leans in toward his instrument, and his forehead brushes the ground wire. A witness describes an arc of fire jumping from Royce's head to the machine in front of him. In Pittsburgh, the manager reports current strong enough to bring the platinum contacts close to melting. And, in his words, streams of fire coming out of the circuits. Some offices recorded messages on chemically treated paper. That night, station after station, the paper caught fire on the desk. Which brings us back to Boston. The operators there can't work at all. The current coming down the line is stronger than anything they send, and it writes straight over the top of them. So the Boston man asks Portland for something strange. Cut your battery off. All of it. 15 minutes. Portland disconnects. Boston disconnects. And then Boston taps out the line I keep coming back to. We are working with the auroral current. How do you receive my writing? And Portland answers, better than with our batteries on. They stayed on the Aurora for the better part of 2 hours. Ordinary traffic. Names, times, prices. The first conversation in history carried on the power of the sky. Carrington then did something braver than the observation. He suggested a connection. That what he saw on the sun at 11:18 and what happened to the Earth the following evening were one event. It was not well received. Nobody could name a mechanism. 93 million miles of nothing sat in between. Lord Kelvin later ran the arithmetic and declared it impossible. The sun could not hand us that much energy. He was wrong for an honest reason. Nobody yet knew that space isn't empty, that the sun doesn't only shine at us, it throws things. Carrington was right in 1859 and waited 100 years to be told so. Now here's the part that keeps space weather people awake. In 1859, the storm had almost nothing to break. One kind of wire, a few thousand operators, a world that otherwise ran on horses and coal. It burned the only technology we had that could feel it at all. And since then, we have wrapped this planet in exactly what that storm feeds on. Long conductors, continental power grids, pipelines, undersea cable. 1989. A storm a fraction of that size puts the province of Quebec into darkness in about 90 seconds. 6 million people. May 2024. The strongest storm in 20 years. Lines trip. Transformers run hot. And across the American Midwest, mid-planting, GPS tractors wander out of their own furrows. A National Academies workshop put numbers on the serious version. A severe storm over the United States. More than 350 high-voltage transformers damaged. 130 million people without power. Those transformers aren't kept in a warehouse. They're the size of a house, built to order, and the queue is measured in months. First year, $1 to $2 trillion. Full recovery, 4 to 10 years. And then there is the 23rd of July, 2012. The sun threw off an eruption in the Carrington class. It crossed the Earth's orbit cleanly. The Earth simply wasn't at that point yet. It hit a solar observatory instead. The only reason we know how big it was. We found out 2 years later. 9 days earlier, that same region had been pointed straight at us. The scientist who measured it said that if it had hit, we would still be picking up the pieces. We do watch for it now. There are spacecraft parked about 1 million miles upstream, between us and the sun, measuring the wind as it goes past. That's the whole warning system. It buys somewhere between 15 minutes and an hour. For something as fast as 1859, closer to 15. 15 minutes to decide whether to switch off a continent on purpose. Because that is the plan. You drop the load yourself, take the blackout, and keep the transformers. Somewhere on the sun tonight, a sunspot group is turning slowly toward us. Nearly all of them do nothing at all. But if one of them ever does what that one did, the first thing you notice won't be an alarm. It'll be the light. A red sky, much too far south, much too early. And somebody, somewhere, will get out of bed and start making breakfast. This has been Lost Signals. Keep listening. The transmission ends.